In 1895, Henri Becquerel, he's the man with the moustache, discovered that rocks of uranium affected photographic paper. This is the rock of uranium that he looked at, and it's called uranyl nitrate. If you look at it, you can see it's yellow. It shouldn't be yellow, that's because it's giving off light. This means that there is some evidence in the rock that there's energy being given off, which affects the paper and which gives out this light. This was the first evidence of radioactivity. However, there was no indication of what this energy source was. It was only with the discovery of other radioactive materials that a pattern started to emerge. The radiation got sorted into three types. We're going to talk about these three types now. So let's introduce the first one. Here comes alpha. Alpha radiation is very easily stopped. It's stopped by air. Look, it just goes into the air and stops. Even a piece of paper, if you put a piece of paper in front of alpha radiation, it can't go any further. It's also strongly affected by a magnetic field. So here we've got a whole beam of alpha particles, and these alpha particles are going through a magnetic field. And when they go through the magnetic field, they bend quite a lot. This tells us two things. One, that it's the heaviest of the radioactive particles, and two, it's the most heavily charged type of radiation. The symbol for alpha is this, the Greek letter alpha. It's not very penetrating. That means if it actually hits something, it stops. Penetrating tells you how far it can get through things. The second type of radiation is more difficult to stop. So in other words, it's more penetrating. It is stopped by about 0.5 centimetre of aluminium. And although it's affected by a magnetic field, so remember the alpha particles bending off to the right, then the beta particles would bend off to the left. This is beta radiation. It's much lighter than alpha radiation, and the particles have got a negative charge as opposed to a +2 charge on the alpha radiation. This is a symbol for beta radiation. The most penetrating of the types of radiation is gamma radiation. Gamma radiation goes furthest in air, it goes a long way in air, and also it goes through aluminium. But it will get stopped by lead. Gamma radiation is not a particle like the other two. Gamma radiation is a wave. That means it's just pure energy, which goes up and down as it goes through the air. And because it's got no charge, and it's got no mass either, it just keeps going. And it's very, very difficult to stop. So gamma radiation is the most penetrating. It has no charge and it has no mass. And it's not affected by a magnetic field.